Hi, I'm Ya Cho, the first author of this paper, and now I will introduce our paper. Detecting undefined and unseen anomalous events between the normal events is challenging. In this image, both person running in the park and the person jaywalking across the road acting running motion, but one is considered normal and while the other is abnormal. In real-world scenario, we know whether it is normal and abnormal event by reasoning the relationship between the foreground motion and surroundings. Human visual systems perform scene understanding through the relational information, which is crucial. Therefore, in this paper, we propose the relational modeling method between context and motion to understand the complex and diverse abnormal scene. Weakly-supervised video anomaly detection is the task of detecting frame-level anomalies using video-level labels training data. The most previous works learned through the multiple instance learning based approach with weak labels. And many methods extract motion features by utilizing object flow data to focus on moving parts and focus on temporal dependencies to consider multiple scale temporal information. There are several challenging issues in VAD. First, there is a limit to discrepancy of features extracted from a single branch model for enlarging the gap. Second is the boundary between the normal and abnormal is ambiguous, which limit to regression learning that forces that the predicted score of snippets to a fixed value. Third issue is that focusing only on motion or temporal information leads to an incomplete understanding of the complex scene. Because in real-world scenario, for complex and diverse scene, the definition of a normal event can differ depending on the context and motion relationship. To overcome the aforementioned challenges, we propose class-activate feature learning method to implicitly activate representative features from a single branch for each class. Also suggest the distance learning that adjusts the interval between normal and abnormal through relative feature distance rather than individual values such as magnitude or score. Furthermore, for the first time in WVAD, we address the importance of relationship between static and dynamic information and propose a context motion interrelation module, which is COMO, that has a dynamic path and context path through focusing on motion and appearance in the scene for modeling the relationship between these two information. So therefore, here are our three main contributions. In the figure, firstly, CLAV feature enlarging the gap by distance learning and explore the relational information through the COMO. And there has no first alarm in the normal video, which is the basketball game scene with the physical fighting, and shows a accurate temporal localization in the abnormal scene, which is fighting. This is an overview of our framework. First, implicit task activation model is inspired by the cross-domain task method. It first expands the channel size and performs split and max activation. This activation, according to the specific characteristics of the individual classes, showed powerful effect with a simple configuration of the single 3D convolution layer. Extractive features are trained by class-specific learning through the encoding and decoding process. Model learns the training data patterns or distribution by minimizing the difference between input and reconstructed output data. As normal and abnormal have ambiguous boundaries and are difficult to define, it is necessary to learn the consideration of the relativity. Shown in the figure, Most MIL-based methods simply regress the anomaly score into the fixed value, 0 or 1, and magnitude learning method enlarges the magnitude value of normal and abnormal feature. Our proposed relative distance learning enlarges the hard negative normal feature and positive abnormal feature distance according to the normal feature center distance. In this way, our proposed laws consider relative feature distance rather than the individual values, such as magnitude or score. In COMO, by predicting the motion information of the snippet through the dynamic path, a static feature or low motion intensity is selected and passed through the context path to extract the fcont feature containing the context information. After that, by considering the interrelation between the context and the class representative feature containing the motion information, the features are projected into the interaction space, and the finer features is output by propagating the relations through the graph-based reasoning network. The proposed method is evaluated on 4 real-world anomaly detection benchmarks. These are the comparison and ablation study results. And this shows the failure case of our method. In figure A, the person passes by the roadway. The walking behavior is normal but shows a high anomaly score through the relation of the surroundings. This scene is an ambiguous case that can be viewed as an abnormal event, which is jaywalking, depending on the definition. This problem of ambiguity boundaries is a limitation to be solved from the point of the view of the applicability to the real world. And the bottom figure is the qualitative results, which shows the anomaly scores. Thank you for watching.